Welcome back, everyone. Hope you had a good afternoon. Hope the homework's coming along well. Our TA has some office hours right after class today, so if you're still struggling with that, go see him. See if he'll help out. Um, yeah. Um, I hate to do two different programming styles back to back, but we kind of have to get through this material just so you have some idea of how Python works before I release the project to you to think about, which I'm hoping to do by Thursday. Um, so yeah, let's talk about Python and PuLP. So Python is a nice programming scripting sort of language. It's fairly legible as far as those sorts of things go. And you can it has a lot of different IDEs, which are sort of development interfaces where you can write up and have their own debugging kind of softwares. And it has a bunch of add-in packages that you can tack onto it. What we're going to be using is PuLP, which will let us write models in Python and solve them in Python. This is not the most powerful solver, but it is a popular one that does not require a license to use. Um, the two kind of flagship solvers are Cplex and Gurobi. They both have free licenses to academics, so you as students of a university would have access to them. However, they're not you do have to fumble with the license, get it in the right place on your computer, and it's kind of a mess. And I don't really want to deal with that. So instead, we're going with PuLP. A lot of people like it anyway. Compared to Excel, um, it's it's more powerful. You can use more variables and more constraints, and you can add them sort of iteratively without having to create a new box cell within Excel. And I don't know. I like it better than Excel personally. A lot of people don't. But you're welcome to form your own opinions. We will be using both of them in this class. So if you don't have a Python installation already, the one I recommend is Anaconda. I think I sent this out an announcement before. It's got it's just a nice installer for Python and a variety of other sort of extra packages, and it's a great way to handle installing additional packages like PuLP. So I think that's fairly straightforward, that installation process. So the next thing you need to do to get PuLP after Anaconda is installed, I think you probably need to restart your machine, and you're going to open up on Mac. You just open up a terminal, um, which is sort of a command line interface. And on Windows, you open up Anaconda prompt, um, which I had to do. I had to open it as an administrator. I think that's because my Anaconda was installed across several users on my machine. Um, but if something's not working, try running Anaconda prompt as an administrator. And then you're going to type this command in the command line, which for whatever reason is 2 lines. This should be 1 line. But conda install -c conda forge PuLP. So this is going to tell Anaconda to install PuLP and all of the packages that it relies on to function. Oh, here you go. Open Anaconda prompt as an administrator. It's just a terminal on Mac OS. So then, so this is what my Anaconda prompt looks like. I typed in the conda install -cforge conda forge pulp and hit enter, and then it collects the packages that it needs to install, and it gives a whole long readout of things. And it asks you yes or no. Do you want to install all this here? Just hit enter, and I'll say yes. And then once that's complete, open up Anaconda Navigator, which came with the Anaconda package, and it has all of your sort of IDEs that it comes with. And I'm going to be showing Spider is the place that I do all of my coding. But if you have a preferred one already, go ahead and use that. I don't particularly care. This has access to PyCharm and Jupyter and most of the popular ones. So that is the end of the slides here. So I'm going to jump into Spider real quick and show you the same examples that we showed yesterday in Excel. I'm going to do them again in Python. All right, is that showing up well? I'm great. I'll zoom in on the center code here after I give you a tour of Spider. So over here, now when you open it up, it may be in a different layout. Um, you can kind of drag and drop these sort of side pieces in different places. I forget exactly how you do that, but this is how I have it laid out. I have my file explorer over here, so I'm in our class directory on my computer. And over here we have the console for Python. So this is where Python is actually running and doing its thing. And up here we have some variables and plots, which will come up later. And in the middle we have our scripts, so the spot that we can actually write the code to do things. So I'm going to zoom in on this centerpiece for us, just to make it a little bit bigger. Yeah. So this is my Python write-up of the same the Soylent problem from before, the same one we did yesterday. So the first thing we need to do is a Python script. Even though we've installed PuLP, Python script doesn't necessarily access that willy-nilly. You have to tell it what packages you need. For this script, we only need PuLP, so I write import PuLP up at the top, right at the beginning. In Python, the pound, the hashtag, is a comment. So if I were to type hashtag import, suddenly this line is no longer being executed, just because it has a comment. This is useful for if you want to write about what a specific line does, which I'll do here in a second. So there are two, moving on, there are two primary sort of tables in Python. First is a dictionary, where we use curly brace And I want to highlight this one first. So we use a curly brace, and then we write a string of characters in quotation marks, or I think you can do integers as well. And then a colon and a value. So this will let us look up this value by asking for deliciousness. I'll show you how to do that in the console shortly. But here we have a nested dictionary. So we have one dictionary. The key is blue. So this is our blue variety of Soylent. And so, yeah. And then if we come over to the console, well, I need to run this first. Up here in the variables, we can see we can click on different variables, and it will give us a readout of what we have here. But if I call a dictionary, it'll give me the dictionary. Call a dictionary, and then use a square brace, and I want blue specifically. It'll give me that first sort of inner dictionary that corresponds to the blue variety of Soylent. If I do the same thing and then I ask for deliciousness, it'll print out the specific numerical value associated with the deliciousness of blue. So that's what dictionaries are useful for. You can also use a list, which is just a square brace instead of a curly brace. Excuse me. And it will index these things differently. It doesn't use the keys, it just uses numbers. So this is just a matrix, really, a nested list. So if I ask for a list 0, it'll give me the first sort of inner list. Python indexes, its first index is 0. So in other languages, Mathematica, for example, if I wanted the first index, I would say a list 1. And that would give me this result. In Python, it starts at 0. So the 0th entry is the first entry. And that has some advantages and disadvantages that I'm not going to get into because I'm not a computer scientist. But you have to keep that in mind as we go through this. I won't be doing a list just because I think dictionaries are a little more legible for teaching purposes. So we'll be proceeding with the dictionary. Here I've just set A to be the dictionary version of A. So now I can call the dictionary just by asking for A. If this is confusing to you already, welcome to the club. There are many tutorials on the basics of Python, and I would recommend looking at that stuff. You should be able to reproduce models and things for this class by looking at my example code and using that. And using other example code that I'll supply. But if you're having difficulty with it, look up some things on YouTube, ask me in office hours. I'll be happy to help illuminate specific issues that you're having with Python. So then, now that we have our sort of data in a format that we like, we can move on to PuLP itself. So the first thing we're going to do is create an object, and that object is going to be an LP problem. So we do this by saying model equals pulp.lp problem. This model, I could replace that with whatever I want. That's just a name for the object itself. So it's common to say problem instead of model, or M instead of model. But what I've done is I've just called it model for now. And then, so we've imported PuLP up here. But to keep Python from getting confused about where different commands are coming from, we type pulp.lp problem, etc. LP problem is a PuLP command, so we're calling a command from PuLP itself. This is an important clause. There are ways around it, but I'm not going to show you that, just so we can all be consistent in our sort of syntax. So pulp.lp problem, we name our problem and we say we want this is a maximization problem. So pulp.lp maximize is the sense that we're sort of solving this problem in. So then we need to define the variables for the problem. Similar command, pulp.lp variable is what we're going to use. So I say xb is our pulp.xb variable. I named it, and I said it has a lower bound of 0 and an upper bound of none, and the category of variable is that it's continuous. So you can do continuous, integer, binary. There are several more advanced categories of variable. But the main ones we're going to use are continuous, integer, and binary. By default, the lower bound on variables is negative infinity. It does not have a lower bound. So for most of our problems, we're going to have to define the lower bound. Upper bound, it defaults to none. So I can get rid of that command and it won't change my model at all. Some of these arguments in commands are optional. Upper bound happens. The bounds are optional. They have default values. They're none. So I've done this 3 times. So blue, red, and yellow are our variables. And now we have to move on to the objective. So you've all seen the written out model. If you remember, it's the deliciousness value times the variable. So xb times a. A, remember, is our dictionary. And then we ask it for blue and deliciousness. So these brackets, I kind of glossed over them before. They're indexes within a list or a dictionary. For a dictionary, you're going to use one of the keys, one of the strings, to ask for something. If I asked for these in a different order, so if I asked for deliciousness first, it wouldn't know what to do because the outer dictionary is blue and a value. The value happens to be a dictionary. It can't see that far into the dictionary. So I have to do it in the order that I've set it up. The outer sort of key is blue, and then I ask it for deliciousness. The asterisk is a multiplication. You need that to multiply, unlike another language like Mathematica. You can just add a space. But in Python, you need the asterisk. And then we add that to the red deliciousness times amount of red, yellow deliciousness times amount of yellow, and we divide that by 30 to get the average. Is anyone horrifically confused about what I have presented so far? All right. I'll keep an eye on the chat, and if anything comes up, let me know. I guess I didn't talk about this half of the syntax. So remember we defined model to be our LP, and this just says that the model, we're going to add something to it. Specifically, we're adding an objective here. But all we do to add the objective is plus equal and then some function of our variables. And our class is going to be a linear function. Then to define the constraints, we do a very similar thing. Model plus equal, some function, and then our inequality. And PuLP automatically differentiates between objectives and constraints when you have an inequality there. So very similar idea. The kilocalories for blue times the amount of blue, kilocalories per red times the amount of red, etc. Greater than or equal to 1500. Fats less than or equal to 20. Proteins greater than or equal to 100. And the total amount of soylent should be 30 cubic centimeters. So that's all our constraints for this problem. And then we just say model.solve with it does require those parentheses there because this is a command, and it does have optional arguments that we could slot in there. If you don't use the parentheses, it will be confused, and I'll think it's an aspect of model and not a command. It'll get confused, and it won't give you the solution you want. So then, just so I can see what the solution actually is, I ask it to print a few things for me. I say print status, so I'm labeling the row it's printing. This is just a string. Anything in quotation marks, or even single quotation marks like this, Python will convert to a string, and the print command will print that directly. Then I print PuLP, so one of our commands from PuLP. The command is LP status, which is going to return the status of the model. Has it solved? Was it unbounded? Did we find a solution or not? And then we call we index it with model.status. Model being the same object as before. Similarly, I want the objective value to print out, so I say model.objective.value as a command. And then I want to know the solution. I want to know the optimal values of each variable. So I say for v in model.variables. So this just will return a list of the variables in the model. And then this for command is going to iterate over each element of that list of variables. So on a given for loop, for iteration, our first variable, right, is xb, So it's in its own internal memory, it's going to set v is xb, and then it's going to use that within the for loop. So I'm going to ask it to print. This is a tricky sort of statement. This f means that I'm going to replace something in the string. And what I'm going to replace is surrounded by curly braces. So within the string, I'm going to replace v with its value from the for loop. And then I'm also going to print the variable value. So there's just a couple ways to print different aspects of the model. So let me pull out the console real quick so we can see what happens. I'm going to press F5, or there's a button, there's a run button on the top bar, but I'm just going to press F5. And it prints out an optimal solution. It's a status optimal, objective value 0.2 and change. XB is 0, XR is 0.3 and some change, and XY is 29.6 and some change, which you'll notice if I pull this up, is the same value that we got on our Excel version. So we're in agreement, so things are going well. That's good. So this is maybe the sort of way to write the model, explicitly give commands to write every aspect of the model down. Maybe I don't want to go through, maybe my model that I'm trying to write up has 100 constraints or 10,000 constraints or however many. I can't do that one by one. Fortunately, we're on a computer, and a computer is good at repetitive tasks. So I'm going to model the same problem in sort of a more compact and scalable manner for us to think about. I need to import another package called pandas as PD. This is a sort of data structure, data handling package. Lets us create interesting ways to store data. And when I say import pandas as PD, that just means that instead of writing pandas.excel file, I only need to write pd.excel file. And Python will recognize PD means pandas, so we're pulling this command from pandas. So what I've done is, not that, I have rewritten our data from the Soylent problem on a different Excel worksheet. I've just put it in the top corner, and on the B sheet I have put our constraints. And then I ask, let me zoom in a little bit. I say, and I've titled it soylentdata.xlsx, and I say I want pandas to open that Excel file, and then I want pandas to read that file, but I want it to read the worksheet named A. And then I set that to be A as our matrix of data. Now the pandas data frame asks for an index, and I want to index on the variety column. Oop, that's not what I meant to do. So I'll show you what that means in a second, but you'll notice that I have the same command here from worksheet B to get our constraints data as a separate data frame from A. So let me clear all the variables from the last go around. And I have the Excel sheet open. If you have the Excel sheet open, Pandas will not be able to access the Excel sheet, so it needs to be closed. But here we have our data frame, A. And notice that it has indexed things on the variety side. So if I ask for, in the console, A deliciousness, it prints out another data frame indexed on blue, red, and yellow. So awkwardly, data frames from pandas, they can sometimes end up sort of backwards from dictionaries. So if I call for blue first, like we did last time, it gets confused. But instead, I want deliciousness and then blue, and it prints out our value. So it's a good idea to, and you can transpose these data frames. There's a lot of things that you can do with the pandas data frame that honestly I am not experienced enough to even begin to get into. I mostly just use it for ripping data from Excel, and then yeah, because it's easier than the built-in method, I think. So, but it's good to know what order your sort of indices are in. In this case, it's backwards from the previous problem, which could be confusing. So let's move on. We have the same exact command to define our model as an object within the Python. And then I can define my x variables, all three of them, as a single command. So I say PuLP LP variable dot dix, which means that we're going to create a dictionary of variables, and the dictionary is going to be named x. So I asked it for a dot index, and it's very small down here, but it spits out a list of the indices of that data frame, which is blue, red, and yellow. So then I name our variables x, and then inside parentheses I say for each index that A has, create a new variable. That's what this means. It does need to be wrapped in parentheses for this to work, because it's creating a tuple, which is an ordered list of variables. And then again, because the lower bound defaults to none, I need to define the lower bound. But I don't need to define the upper bound because we don't care about the upper bound in this problem. So instead of 3 commands, 1 command for every variable in our problem, I can condense it down to 1 command. And additionally, if I put in a larger, if I add more varieties to that Excel spreadsheet that had our data in, this this program is automatically going to include that in A and include that new index for whatever variety I've added straight to the variables, which is convenient. Defining the objective looks very similar. I've put it in summation notation here. So I've said the sum of the deliciousness of variety I times the amount of variety I for I, and this is summed over all of the i's in a.index. This might be a little confusing to look at. Basically, we're creating a vector of size, the same size as the a.index, so all the indices of A. And then we're assigning each value of that vector the coefficient times the variable. And then the sum command is summing the elements of that vector together. It's adding those together. If you're familiar with Python, you should be familiar with this. If not, it might be a little tricky to read at first. And then I divide by 30 again to get an average. For the constraints, now I can't pull up, well actually I can pull up B. This is B. It has whether or not our constraint, or what inequality direction our constraint has, and it has the value of the right-hand side for that constraint. And so this is, because this problem has greater than or equal to, less than or equal to, and equal to constraints, in order to make it sort of expandable, I had to use some if-then in here. Let me space these out a little bit. So for every key in A, if I ask for the keys, that spits out our deliciousness, kilocalories, fat, protein, and a column multiplier, which I'll talk about shortly. So for every one of our sort of aspects of our different varieties, we have a constraint on that, right? If the equality row in B is equal to the is equal to this string, greater than or equal to, then it's going to add a constraint. This is telling me to move something away from the shared window. Is this showing up correctly to you? Something is angry at me. All right. We add a constraint just like we did before, but it's in a more general format. Again, we use a sum. AJ is the key for A, so that's going to be calories would be the first one, times blue, the calories for blue times the amount of blue, and then sum that up for all the different varieties of Soylent. And then that's greater than or equal to b times the b j and the constraint row. Hopefully this won't be difficult to take and modify yourselves if it's confusing to look at. But similarly, we continue on. If this is not true, then maybe this is true. Maybe it's a less than or equal to. You do the same exact command, just replace this with a less than or equal to. If that's not true, then maybe it's an equality rather than an inequality. In that case, we add a double equal sign. It's important to have a double equal sign because that is how Python, so a single equal sign sets a variable to a value. A double equal sign asks Python, is this true? Are these the same thing? So that's what the double equal sign is. And we also need that in the if lines. And then model.solve again. And let me run it. And we have, over here in very small text, the same result as before in the other version. So this is sort of the more robust and scalable way to write the same problem. When you're turning in code for a homework, either if you want to write out all the constraints individually, go ahead. This first stuff you'll do for the homework will probably not have too many for that to be impossible, but it still might be uncomfortable. But whatever method suits you at that moment. So let's move on then, unless someone wants to know something specific about what I've done here. And I am fully expecting to have to talk with people in office hours about how Python is working, how exactly the language and the syntax works. So don't be afraid to ask about that stuff. What is this? Yeah, get these out of here. Alright then, let's move on to our assignment problem from the book that we also talked about yesterday in Excel. Again, we import PuLP. This time I'm using a list, or a nested list, a list of lists, rather than a dictionary. And I want, because I'm going to be using the dimension of this matrix several times in this problem, I want to go ahead and define a variable to be the dimension of the data matrix. So what I've done here is, let me get rid of that, run this. So data is a list of lists, and M asks for the length of data, which is just 3, because remember that Python indexes on 0, it starts at 0. And then for N, I've asked for the length of data 0, which is the first row in data. And again, that's 4, because this is a square matrix, but that's how I've called for these things. Then we define the model, just like before, different name, and this is a minimization problem rather than a maximize. And then I did the same trick for x, where I defined multiple variables in one row. In this case, they have two subscripts, I and j. So all I've done is duplicate the for loop. So it has for I in the range of m, which means 0 to m, and for j in range n, which is 0 to n. And then I've had to set the lower bound to 0. You could conceivably say category not that, binary here. Zoom out so we can see all that. It wasn't necessary for this problem, as we learned in the Excel sheet, but it might be for a different, similar problem. So then we have add the objective row. Now here's an annoying feature of PuLP. Python itself gets confused when you ask a nested list for an index of a nested list using a comma, like this. So I, comma j would be data first row or ith row, jth column. It doesn't like that comma. So instead, we call for the list that is the ith row, and then in the ith row, we look for the jth element. For whatever reason, PuLP doesn't like when you use the double brackets, and it likes it when you use a comma. At least that's what I have found. It's possible that there's a way around that, but I don't know about it because I've just been dealing with it. So be mindful of that if you're doing multiple subscripts for variables. And then again, we've summed and I've duplicated the for, so it has two four iterables is what it's called. And then our constraints were just the sum over for I is the jobs, I think. Yeah, so each employee, for each employee, they should be assigned exactly one job. For each job, they should be assigned exactly one employee. Model solve. And here I've done something a little bit different. I've said for v in the model variables, I've said, because this has 16 variables, most of them are just going to be 0. I don't want it to print all of that. So I've said if the v dot variable value is 1, only print the ones that have a value of 1. Maybe a more robust way to do this would be is greater than 0. So if the variable value is greater than 0, print that variable and its value. So let me run it again, and we'll see we get an objective value of 7. And if we pull up our Python or our Excel version, we'll see that we got the same objective value using Excel. And in fact, if you compare the variables that are probably too small for most of you to see. And remembering that indexing starts at 0 in Python, we have 0, 2 translates to 1, 3 is 1. 1, 1 is 2, 2 is 1. 2, 0 is 3, 1 is 1. And 3, 3 or 4, 4 is also 1. And everything else is 0. So we get the same solution using both programs, which is encouraging. So I have one more example to talk about, just like last time. I wanted to do the separation problem again. If we remember from yesterday, we were looking to split these two data sets with the furthest apart lines, parallel lines possible. So again, I created a new worksheet that has our matrices, our data sets on different sheets, A and B, and I've used the same pandas read specific sheets idea from before to get our data sets A and B in Python for us to mess around with. And I forgot to close the spreadsheet again. Make sure you close those. Similar idea, define our model, same way, change the name. Define some variables, alpha and beta. Both of them are size 2, so they have a dimension. They have 2 different entries. And then to the model, I want to add our objective function, b1 minus b0. Remember, in Excel, it was b2 minus b1, but we're index starting at 0 in Python. And then because there's only 2 alpha variables, I have gone ahead and written out the constraint explicitly for every I in the length of A. So for every sort of data point in A, we have this constraint, which is alpha times the data point in A minus B is less than or equal to 0. And then just like we had in Excel. And then do the same thing for the B constraint, B1 instead of B0, and greater than or equal to 0. And because there are only 3 degrees of freedom in the model, to be clear, I did not change the, I did not set a lower bound for this problem because we don't care about it. Because there's too many degrees of freedom, I've just set A0 to B1, or -1 rather. And then I ask it to solve, and we get an optimal value of 4. And if we look at our Excel spreadsheet, we'll notice an optimal value of 4 and the same variables, same optimal solution. So that's 3 examples. It's a pretty syntax heavy day, and I apologize if you're struggling to follow along. I'll be happy to talk about Python office hours, etc. Your third homework will be to write up some of the models you've already written before, some of the models we've already done in Python and Excel, and maybe one or two that we haven't seen before, just to get some more modeling experience, because modeling is probably the most important part of this class to you. Maybe second only to how to write them up in a computer. So that is what I have for today. So I will stick around for a little while and answer questions. But if you don't have any, you are free to go. Will this lecture be updated to the YouTube playlist today? Yes. It is also, they are also on Canvas now under the course gallery. I think they're all there so far, and hopefully it will upload by today. Sometimes they take a long time. But the first thing I'll do after signing off is start that process.
Hi, Professor.
Yep.
I will require additional office hour for today's just for my homework because I probably cannot attendance the TA's office hour because I have class just right after this class.
Right.
So you are okay for you after 2 p.m.?
Sure. Just
Okay.
yeah.
Thank you. Appreciate it. So, so you just send me a link by email, or I just click your
Use the one
office.
in the on the syllabus. That'll work just
Okay.
fine. 2 is what you emailed me. What we agreed on, right?
Mhm, yes.
Great.
Okay. Thank you. Appreciate it.
Anything else? No? All right then. Oh,
Hello,
yep.
Professor.
Yes.
Yes. So I had a question regarding the homework.
Sure.
Hello.
Yes.
So uh, I can't really work on it right now, but I'll email you soon. So the thing is, I'm not really sure about the homework, about how to work on it, because I don't really have what's it called, the laptop or a PC to work
Right.
on it. So I'm trying to use my iPad as a as an alternative,
Mm-hmm.
but still I'm still not really sure about how to solve some of the problems.
Sure.
Yeah, so I'll email you soon if I got any problems. And also about the TA, Mohammed Al.
Yes.
So is he available just like you, or does he have other
Um,
uh, like office hours?
he has some regular office hours. Right after class today, 11 to 1, I think. But
Oh,
he
okay,
he
okay.
should be available if you email him
All
for
right.
additional
That sounds good.
hours.
Thank you very much. Thank you very much. I appreciate it.
Thank you for coming out. All right, that's everyone.